Hey, welcome everyone to our fourth stream already. This time it will be all about testing. Before I dive deep into the topics, I want to tell a little bit more about our meetup group. We are the Dutch Android user group, founded in 2011. We have over 1,200 members and are purely on Android focused. Together with my other three organizers, Jacinto, Rob, and Yolanda, we are trying to organize meetups once a month. This currently in the form of live streams. If you want to, if you go to meetup, if you want to go to dutchout.org to subscribe for future events, and to find our Slack group, you can go to the same address /Slack. For questions, or if you have any, or to participate in any discussions, or of course, heads up for our future events. Recently, Android and Jetpack released a lot of new stuff. We're trying to figure out if we want to organize a new event next month about all this new stuff. If you tried anything or want to try something, please let us know. Reach out to us on Slack, on Meetup, or on Twitter. We want to do short lightning talks that we normally always do after I.O., but since we didn't have an I.O. this time, we want to see if we can do it in the form of a live stream. For example, about Hailed, app startup, paging feature, or motion layout. Up next, Alex will be talking about integrating fast and stable automated tests, and Niek will talk about mocking libraries. We have a short break in between, so don't worry. If you have any questions during the live stream about the talk, please leave them in the chat. We will pick them afterwards, after the presentation. They will be seen, so don't worry. Please leave them during the presentation. It will actually speed everything up. Let's start. I will announce Alex, and he will start with his talk about integrating stable UI tests. Up to you, Alex.
Cool. So welcome everyone. I'm Zhukovic. I'm an Android developer and take.com, and today I will speak about UI testing in general, and we'll talk a lot about UI testing in Android, which approaches we can use, which practices we can use for better and stable Android tests. So we will talk about so we will talk about, and I want to start with Android as part of ecosystem, because for testing perspective and of course for development, Android has some specific cases and specific scenarios. And first of all, I want to start with dependencies. When we build and test Android applications, we use many different dependencies. It can be local or remote data storage. We use emulators. On some devices, we have access to Google Play services. On other, we don't have. We also have specific variations of device like PNDs as example, when you have many limitations from software and from hardware. We also have many operation system features like app shortcuts, when you long press the icon and you have additional menu, and of course it also should be tested. Very important information also for testing is that when we speak about permissions, all permissions based on operation level, on operation system level. It's not part of application. And we also, if we want to interact with them, we should do it in a specific way. And of course, we have fragmentations, many vendors which produce different devices with different version of operation systems and different features which are available only on specific devices. So coming back to Android tests, we can split them into local and instrumentation ones. A local test can be run on local JVM. They don't need emulator or real device, and they much faster than instrumentation tests, which of course require device or emulators. Both local and instrumentation tests can be split to non-UI and UI. However, speaking about local tests, UI are available only when we speak about RoboElectric framework. However, with RoboElectric framework, many UI features cannot be tested, especially things connected with gestures, as example, interaction with sidebar. However, with instrumentation test, it's always work fine. However, here we should understand the difference. When we run instrumentation test, first of all, we need to copy application and test application into the real device emulator. After it, we need to run this test, collect some feedback, collect reports, and send them to our workstation. And of course, it all takes a time. So when we run our test case from Android Studio or use Gradle command, under the hood, Android debug bridge will be executed, and two applications will be installed to the device. It's our developing application and test application. When both applications we have on device, they interact based on instrumentation API which are available in operation system. And in this way, test application can test developing application. That's the reason why after running UI test on your device, you have additional application installed, because this application have only test cases. So today I will talk about use cases from this application. This app was created only for UI testing workshop. You can find many test cases and requirements for writing tests, just for practicing writing the UI tests. So this application is pretty simple login screen. You also can create account. You have access to the different coffee drink with short description. In addition to it, you have a map. And on this map, you can find nearest cafes and restaurants, and you can find profile information. So some years ago, Espresso Test Recorder was announced as a super easy and super fast solution, which help us to generate a lot of tests in few clicks. And it was super great announced during Google I/O. Later on, people start using it, and it wasn't super cool announced because it's not always working very well, and very often it's just not working. So let's take a look at small example. And this is example of generated code by by Okay, I hope you can hear me now, and I hope it's working. It's still working. Please send. Okay, cool. So coming back to generated code by Espresso Test Recorder, we can see that it's unreadable and it's unmaintainable. However, sometimes we can use this tool as example when we plan to do some refactoring. And before refactoring, we can apply this tool, record some test. After refactoring, we can run this test. However, for not all cases about refactoring, because when you interact with some data source and your application should just wait some moment, and it's not working, you should update it manually. So this tool generates a lot of problems for us, and it's not working for more complicated scenarios more than working, but still in some cases we can try to use it. So for interaction with UI and know information about UI, as example text, ID, and many other properties, we can use two different tools. It's Layout Inspector and UI Automator Viewer. So speaking about Layout Inspector, in latest version of Android Studio, it was updated. And right now we have a live update feature. We just, when we press something on device or emulator, it's already updated inside application. It's a great benefit that we don't need to do open snapshots, but right now we cannot save snapshot. And it can be, of course, for some cases, it's a problem. And we can, this tool also understand when you use resources from a strings file. And it's really great because we already in test know which resources available. It solves a lot of problem when your device or emulator for testing run in different languages. However, speaking about UI Automator Viewer, this tool provide for us information for any application in operation systems. Because Layout Inspectors can provide you access only for developing application. And sometimes we have operation systems features and we should go outside of application. And for this case, we can use Layout Inspector with root permissions, or we can use UI Automator Viewer and know information about UI from different applications. So I want to start with approaches and tools which we can use for testing and of course for efficient testing Android application. So first of all, we have pretty famous approach which usually used first, it's end-to-end testing. With end-to-end testing, we start from the main entry point of our application. Usually it's splash screen on login screen. Later on, we should interact with our application, do some navigation between different screens. And in this case, we want to go to profile screen, and on profile screen, we want to verify name and email address. But as you can see, we should spend some time for login, some time for navigation, and at the end, we should log out from the application because our app should be cleared for the next test. And of course, in practice, we spend only a few seconds or milliseconds for verification and spend a lot of time for navigation, for clearing data, etc. And it's good approach because it's covered whole flow of your applications, but it's not super fast. And we have other approach. Usually it's called like functional test. And in functional test, we can use mocks, fakes, any frameworks just for mock some layer in our applications, or as example, use debug server instead of production server if we want. We can also use production server if it's needed, but it's not so popular case. So let's try to compare these two approaches. First of all, it's entry point. For end-to-end test, it's a real entry point for our application. Usually it's home screen, usually it's login screen or splash screen. For functional test, we can start application for any screen as we want. Based on interaction with web service, end-to-end test usually use production server because they don't need any specific configuration or architecture for our application. But with functional test, we can usually use debug server, we can mock some data. Usually for end-to-end test, it's navigation from the start to the end of the application or to the required features. However, from functional test, we usually start from a required screen and we have navigation only between neighbor screens or we don't have navigation at all. And these two types of tests have different idea in mind. First of all, End-to-end tests in mind have application verification. It's verification of the flow at fully emulating user behavior. However, functional tests verify UI interaction. We have some data and we verify that this data will be rendered correctly and properly. So let's speak a bit about tests, about frameworks which is available for Android, because all these approaches can be applied not only for Android, but only for any other technologies. So speaking about frameworks available on Android, we have Espresso, UI Automator, and Appium, and many framework which is based on these frameworks. So speaking about Espresso, it's framework developed by Google. Right now, many people use it, and it's have pretty clear API. As example, in this case, we are looking for a view with ID email, replaced some text, looking for password, also enter password, and check that login button is displayed. As you can see here, we use different operators like perform and check. We can combine them in one step, and we can find view, check that view is displayed or have some possibilities, and after it just do some action with it. Very important information here that Espresso supports synchronization. When you move from one screen to another, you shouldn't wait some time. Espresso do all this stuff for you. Espresso also use idling resource mechanism, which help us and give possibility to configure waiting time, because when we get data from the backend or from the database, it should take some time, and Espresso using idling resource mechanism will wait for it. The main problem with Espresso is that we can interact only with our application. However, if we want to check notifications, which is part of operation system, we cannot do it with Espresso. And the really cool benefit that we can run our test from any required screen, and we don't need to spend time for navigation to the screen. However, your application should be built in this way, because unfortunately many applications require a splash screen, as example, from the very beginning, because splash screen initialize some data, and this data is super important in other part of the application. If our application allows us to run from any activity, we can do it. UI Automator, it's also a framework developed by Google, and this framework allows us to interact with any application inside operation system. If it's interesting for us, we can take any application and write test or scenario for it. This tool I also used just for fun for removing some stuff from other application. As example, if you have some music saved in favorites, you can just run simple script and remove all this music. This scenario I wrote for fun, but it's actually working, and I don't need to do it manually. So the next tool is Appium, which is under the hood use UI Automator. At the beginning, Appium was sold as cross-platform solution for writing cross-platform tests. However, it's not really it's cross-platform tools which support many languages, but in practice, iOS application and Android application looks differently. Sometimes UI looks differently. Sometimes they even have different behavior. And in practice, when you try to use Appium as cross-platform solution, you should write one test. Yes, Appium using UI Automator under the hood, exactly. It can interact with any application with operation system. But if you have two different applications, iOS and Android, you should run one test, but different steps for iOS and Android. And from my perspective right now, Swift and Kotlin pretty similar. And if you create DSL, we don't really need this support for a cross-platform tool. And recently, when I checked Appium website, they don't try to sell it right now as a cross-platform framework. So let's try to compare some very important features of this framework. First of all, it's a support of Android resources. Mostly I'm speaking about translations, because if you use native way of building translation in Android, you can, with Espresso, you can interact with resources. However, with UI Automator and Appium, you cannot do it. And of course, it generates some problem. As example, our device should be always prepared and set up in correct language. But if you have access to resources and your application set up to Spanish, from your application will be get Spanish resources and used in your test. And of course, it's simplified writing tests. The next very important thing, it's supported type of test. Appium and UI Automator support only black box testing. We don't know what we have under the hood. We know what we expect and how it will react for us. So Espresso also use different type of test. It's gray box. It means that we can interact with application. As example, mock some data, provide some configuration, usually via dependency injection. And the most important information here is execution time. And as you can see, Espresso much faster than UI Automator and Appium. And that's usually why a lot of test cases in many companies based on Espresso. And really great news that you can combine Espresso and UI Automator even in one test. It means that we can start our test with Espresso. Later on, when we need to interact with other application, we can use UI Automator as example for checking notification or for pressing hardware button, like for testing how our application check when user lock screen. So let's come back to our application and try to define one general scenarios. So here we should log in, navigate to the profile, check a name and email, and later on log out. And here I want to concentrate on framework which is based on Espresso, because with Espresso we should write a lot of similar code. Even when I had provided a workshop, people start writing small function on top of Espresso, because with Espresso you should write a lot similar code. And of course, it's not very great for maintaining and supporting in future. So the first such framework is Barista. Barista have some simplified API and assertions. Also, in addition to it, we have additional rules for clearing data, shared preferences, database, and files, and some features for working with Flaky test. So, what is Flaky test? Speaking about Flaky test, it's when you run the same scenario and sometimes it's pathing, sometimes it just fail. And of course, we don't understand it's fail because it's Flaky test or it's fail because it's just not working. And for this, first of all, the best solution is try to fix such test. But if we cannot fix or we don't have resources right now, we can just use a few methods. First of all, a method from Barista is allow Flaky and number of attempts. So when we run a framework with some attempts and as minimum once this test pass, it means that this test is working. With repeat annotation, it should always pass. If it at once fail, it means it failing. So we can write the same scenario with Barista framework in this way. It's Barista, it's Espresso-based framework, so we can use idling resources for mocking some data. And if I remove comments like login, navigate to profile, verify profile info, etc., it will be super unreadable. it will be super unreadable. So the next framework, which one of main feature its readability, is Kakao. Speaking about this framework, when you read this part of test, it's much more readable. And if you open your application, you can just read and understand it. Because we are on login screen, we enter some email, enter password, close keyboard, and just press to the login. It's much more readable. In addition to it, Kakao framework has interceptors. It's layer between Kakao and Espresso, and as example, you can add additional login with interceptors. If your step failed, you can just repeat the failed step without any problem. And it's also additional benefits for this framework. And the last framework is, let's come back to our scenario and rewrite the same scenario with Kakao framework. As you can see here, it's much more readable. We on login screen, we enter email, password, press login. We on home screen, we just click to profile menu navigation, etc. It's much more readable, and even person who not familiar with writing test can read and understand this test. And of course, it's much better from readability perspective. The next tool which we have is Kaspresso. Kaspresso is based on top of Kakao, but also provide additional benefits and additional dependencies. So, as it's based on Kakao, the simple example will look the same. However, in addition to it, we also have tools like KAutomator. KAutomator, it's a specific version of UI Automator. And KAutomator reduce waiting time when we can send additional zeros to the view. That's why we can get data faster. So the next step, we also can inject data into the DSL. We can interact with device because Kaspresso is combination of Kakao plus KAutomator, which is very often under the hood UI Automator, but with additional features. It also have advanced reporting system. You can do it easily. And we can also handle flaky tests because of interceptors from Kakao framework. So it's the same sample with Kakao framework, but we also have before test, after test, and run, which of course can be excluded. In before test, we can prepare something to the test, as example, run activity or fragment. With after test, we can clean up something after our test, and with run, we just run our test, and it will work well. And in practice, Kakao is the fastest framework because of KAutomator. And for instead of idling resources from Espresso, under the hood used KAutomator, and it's working very well. So let's coming back to our UI, and our UI usually based on some data sources. And one of data source, it can be database, it can be web service. Sometimes it can be different sensors. So if it's a database, before the test, we can pre-populate database with, as example, queries. This way, it's much faster than just generating data based on UI. Speaking about web service, we have different tools. We can use debug server instead of production service, or we can use, as example, mock responses using wire mock, rest mock, and other one, or we can just use fake layers, or just mock some layer in your application. But here's a very important part, what you try to test with your UI test. If you want to check how your UI react on some data, you can just, as example, can mock some layers. As example, mock responses from view model. It means that inside your test, you wouldn't check how how repository collect data from different data sources, how it handled by a view model, and later on rendered on the screen. If you want to do all this flow, I recommend pre-populate data in database and use WireMock. But it really depends what you try to achieve with your tests. The very important part is navigation in our application. We have usually two approaches. First of all, it can be two different activities on one activity and multiple fragments. Of course, it can be combined, but it's not so important for test. Fortunately, right now, both of these approaches we can test with Espresso and Espresso-based framework without any problem. So, speaking about interaction with activity, we have activity test rule. And when we use a latest parameter as a false, it means that this activity wouldn't be started before the test. It means if it's false, later on we can inject some dependency, as example, mock some data and start our test, and later on start our verification. Speaking about testing fragments in isolation, we can use method from Espresso, launch fragment in container, and put our container. In practice, under the hood, the simplest activity will be created with one fragment, and our fragment will be inserted to this activity. So in this case, it will be pretty simple. Right now, we have predefined a command for it because few years ago we should do it manually, and right now it's part of framework, which is always good. So how I propose to achieve efficiency? End-to-end test, which start from the very beginning and go into the required feature later on, usually for logout, take too much time, and these tests are needed because these tests verify our real backend, not some mocks, and also not some fake data. Because if we use only functional test and our backend was changed but wasn't synchronized with debug web server, we will have an issue, because with our debug web service, with all data, everything will work fine. But with real production server, with updated backend, it wouldn't work. So I propose to compose end-to-end test and functional test. And we don't need too much end-to-end test. Usually it's used for happy path, and a lot of other stuff we can cover with functional tests. We can check that if we provide such data, it will be rendered in a proper way. In this combination, we will have few, maybe not few, but not so much end-to-end tests, which is pretty slow, and many functional tests, which are pretty fast. And in this way, we can achieve efficiency in our testing, and it will be pretty fast for UI test. Of course, not so fast as unit test, but still much faster with this combination. So right now, I want to speak about DSL, or domain-specific language. It's specific language for our application. With this approach, as Kakao and of course Espresso, which is based on Kakao, try to solve problems. And speaking about DSL, it's specific language for our application. And everyone can read this language and understand it, even if this person don't work as a tester or don't write test. If you open application and will read such test, everything will be clear. So let's come back to our scenario and refresh it in mind. First of all, we should log into our app, open profile screen, check name and email, log out from our application, and clear some data at the end. So this API based on page object and roboto pattern. And as you can see, for the same scenario, we can build many different versions of DSL. First of all, let's take a look at login screen. And inside login screen, in one case, we have only one method, login, with email and password. In other case, we have three different methods: enter email, enter password, and press login. And the main reason of different approaches that different way of testing the application. If you prefer to write only end-to-end test, for you just one login method will be simpler. However, if you want to enter only email, and this email wouldn't be in practice email, it just be just a string, which is not much with email pattern, and you want to verify some error, of course, for you will be much faster to have write enter email, and later on you can verify. So in practice, you should understand way which you plan to test your application, and only after it start creating some DSL. This pretty similar example you can have in home screen, because in one case we have only method navigate to profile. However, in other case, we have wait a coffee drink. We wait when data will be loaded and displayed on the screen. In practice, in home screen, when we have only one method, we call this method under the hood. However, if you plan to use functional testing, this method is not always needed. So in some cases, it's much better to have more detailed method. In some cases, it's general. Of course, you can combine them. So let's try to convert this simple login action into one of variation of our DSL. So I propose to start with basic operations because it's the most reusable part of our domain-specific language. And here we have enter text and click on view. In both cases, we pass view ID. And in enter text, we also pass a string. It's pretty basic Espresso operations. So later on, we can create our operations for our login screen. And in this case, our function require email and password, enter email, password, and just press login. And at the end, we create a functions which help us to call all functions from login screen robot inside these functions, which make it super readable. Speaking about this approach and roboto pattern, I really recommend store all frameworks like Espresso, Appium, or other frameworks inside basic operation level. Because if one day you plan to switch from Appium to Espresso, you can just update all basic operation and other part of framework will work perfectly. And you don't need to provide any changes and any adaptations for it. So let's try to summarize creating even simple DSL. First of all, it increased readability and reusability. When we created a login method, we can use it in many places. When we have pretty small methods, we can even reuse it more. DSL have huge problem with building complexity, because first of all, we should have requirements what we plan to build, and later on, we should understand it's super complicated to build from the first time great DSL, because your requirements will be changed and you should adapt it, and very often it can be a mess. But if you try to create more and more times different DSL, it will be much better. And maybe not from the first iteration, but after a few times, you can create DSL from your needs, especially for tests. And we have all our dependency. I recommend to use into the basic operation and make it independent on the top layer of the framework. It means you can one day pretty easily replace one framework to another. So, as I told at the beginning, local and instrumentation tests can run UI test. So let's try to create a shared source of our UI test. And our idea is to store all our tests inside one place and later on have possibility to run this test as local or instrumentation tests. So we can change our build.gradle file and update our source set for local and instrumentation tests. It means for Android test and tests. And later on, everything which is available inside shared test will be available for both Android and instrumentation tests. Speaking about local test can be used with Roboelectric framework, and we can run them UI, or general local test can be run on JVM. Instrumentation tests require a device or emulator. So when you already have some test, it's not a problem extend your coverage or cover most. Yeah, it's enough. Okay. Okay, I propose to start introducing UI tests if you don't have them in the following way. First of all, with end-to-end test, cover application flow and cover most important features of your application. When these features are covered, your test not so fast, but you can be sure that your application work as you expect. So next thing, it's priority. We have many different screens with many different features, and one screen more important than other one. As example, login screen is one of the most important screen in our application, because if it's not working, people just wouldn't use our app. Setting screen is also important because it helps you to customize some settings and you use application in a bit different way. But it's for sure less important than login. It means that first of all, you should cover features and screen which have much more important for your product, and later on you can cover less important. Because many applications had about screen, and people almost never read the screen. Maybe read, but not so often as other screen. And when your application sometime on the market, you probably have analytical data. And when you have such data, you can see that one option is more popular than other one, maybe because it's set up by default and people don't change it. But based on any reason, let's imagine that people more use TomTom maps in our application. And in this case, I recommend to cover it first, and later on you can cover something which is less important based on analytical data. Usually inside application, we have many possibilities to do something, um, um, uh, to achieve something in different ways. And for it, we can use analytical data and see, okay, in this way, people more use our application in this approach, and it should be test first. And based on these priorities and analytical data, you can cover it properly and have better coverage and more stable application as fast as possible. So I hope it was useful. I encourage you to play more with UI tests for Android and for other platform. Explore more approaches, more different frameworks. I write a lot of article and have pretty big guide, which is not finished unfortunately yet, about UI testing. You can find it on my website. And I encourage you to have discussion on Twitter, and I will answer to all of your questions which I have in a chat. I hope it was helpful for everyone. Okay. So how to automate regression that has email verification. In this case, first of all, usually we can get you can get push notification with our code. If we have push notification and we want to achieve it with UI tests, with end-to-end test, we can use UI Automator, because UI Automator can open all available notification and we can check content of this notification. We can get code and continue with our email verification. Or we can open any other application. Of course, it takes some time. In some cases, you can have one such scenario with end-to-end test. However, if you have many of them, you can also mock some data and or use fake implementation. And in this fake implementation, just set notification and just verify that it was sent properly. And if you put it into the application, everything will work correctly. Yes, the next question is how to deal with flaky test. And it's pretty big and pretty interesting topic. Some framework provides some ways just to repeat them, just to repeat some tests. One of approaches when you cannot really fix them, you can run if test fail. Let's imagine you have 100 tests. At the end, you have that 10 of these 100 tests fails. And in this case, you can rerun on fail test on CI as example a few times. And each time just run less and less tests. And in practice, you can find a way that from this 10 at the beginning failing, right now failing only 2 or 3. Ideally, you should fix them. First of all, I propose to think if this test should be end-to-end, because when it's end-to-end and your test longer and do more and more stuff, it can be more flaky because you can do more different operations. If you can replace it with functional test, it will be much faster and much simpler. It's not always the case, but sometimes it helps you to reduce execution time and also fight with flaky tests. Yes. The next question, how to decide which of UI tests should be run as roboelectric test and which should be run as actual instrumentation test? First of all, roboelectric don't support all scenarios. And if roboelectric doesn't support this scenario, for sure it should be instrumentation test. But what you can achieve, as example, very often you can run all tests as local test with roboelectric. The main issue with roboelectric is that roboelectric always run on the same environment. We can compare it with always running on emulators, but later on we have many different devices with many different ROMs, and it can be a problem. And instrumentation test you can run simultaneously on different devices. So before release, you can run all your shared tests as instrumentation tests, and as example during development you can run them as roboelectric. And as example, when you merge your merge request, it also can be run as instrumentation. Ideally, if you have shared test, you can run both of them. You can run the same test in different ways and use different approaches when it's needed. Okay, thank you for all your questions. If you have more questions, just write in the chat, and in a few minutes I will join to the chat and answer to all of your questions. Thank you.
Hey everyone, we're back. My microphone was muted. Everything can go wrong if it's live. But thanks a lot for your talk, Alex. Really interesting. Second time in a row here. Next up is Niek. He will be talking about mocking libraries. A lot of you know him already from the community. I don't think he really needs more of an announcement than this. So let's go over to Niek. You can.
Yes, thanks, Dion. Yeah, so I'm Niek. I work for an agency called Label 305, and for our apps department, we mainly focus currently on building apps for fitness machines. So we've got a bunch of rowing machines in the office. We got a cycling machine and other types of weight machines. You also may know me from the Mockito Kotlin library, which basically acts as a helper library for if you use Mockito with Kotlin. When I was asked for this talk, I was asked to tell something about testing and mocking. Now you can use mocks to help with testing. And turns out that I realized that I'm not really using mocks anymore. Like 90% of the Mockito features, I don't use them anymore because we've shifted to a different style of programming. And that's what this talk will be mostly about. So let's first dig into a bit of what Mockito allows you to do. This will be a very short overview. Basically, Mockito allows you to provide some mock instances of your classes. So instead of having to implement fakes or something yourselves, you can call some mock method, and the Mockito library will do some bytecode tricks to let your code think you have an actual instance of your class. And these instances will have their methods stubbed out, so they will return null values or a zero if you need to return an int. And you can actually configure these instances to return certain results if you want to. And lastly, you can also verify function calls if you need to verify that some method or public API was called. Problem with this is that using mocks and stubbing really invites you to create messy test code. So this is what what code in a test suite can look like. So at the top we have a mock, we have some users repository interface, and we mock that. And this users repository interface has a users method, and we want to mock whatever it returns. And we even go even further. We mock this list of users, and for the mocked user list, we even mock the getter for if we do a call to the 0th element of the list, then we'll return some user. And at the bottom, you can even verify that this user's method has been called. Now, this is not really something you want to see, but trust me, I've seen this, and I'm quite sure I even wrote code that looks like this. And if you want to maintain this, then it's really difficult. In the last couple of weeks, people have been advocating of stepping away from these mocking frameworks because of the problems they pose, and the alternatives are quite easy. Mainly problems are that the tests are tightly coupled to implementation details, so you'll see that changing your implementation details will also require you to change your tests. And that means that your tests become fragile and you need to actually maintain them. I won't really go into the detail about why we don't want to mock anymore, because there are numerous of articles online. And instead, I want to look at some of the alternatives we can use. So when you're creating a mock, you're actually creating some kind of test double. And I want to have take a step back and look into what test doubles actually are and why do we use them. The test double can actually be used to replace calls to classes that are used in production, and you can replace them with instances to make it easier to test these classes. So you can swap out your database or some network calls and keep your tests running very fast. So Martin Fowler described a couple of terms for these test doubles, which are basically techniques that you can use to swap out these instances. So first we have these dummy objects. Dummy objects are just some instance isn't used in the test, so it doesn't really matter what we throw it into in the system and the test. Then we have fake objects. Fake objects are actually working implementation of the interface, but they usually take some shortcut. This could be an in-memory database or something. Then we have stubs. Those are spies are like stubs. Stubs are like fakes, but they provide default answers to calls made during test, like always return an empty list or always return a list of one element. They're not really subject to change by the test suite. Then we have spies. Those are like stubs again, but they can also record invocations on the instance. So you can check if certain calls were made to the spied object. And finally, you have mocks. And with mocks, Martin Fowler describes it as a pre-programmed instance with an expectation, which form a specification of the calls they are expected to receive. And you can basically view that as setting up a mock with it and stubbing it with the expected things you want to do. For the remainder, I'll focus mainly on fake objects and stubs, because if you have this really simple interface, then you can implement them really easily. So in this case, we have a users repository with a single get user function, and implementing this can be really easily done as a stub. So now we have this stub users repository that implements a users repository, and we just return an empty list. We always return an empty list, and that's it. So a real easy implementation. We can always also implement it as a fake. So now we have this fake users repository, and instead of always returning an empty list, we have this property users that can be mutated, and we return that from the get users function. So in this case, we can, in our test suite, we can actually modify the users variable, say now we want to return some other list of users, and the get users function will return that. So in this case, fakes and stubs are really easy to implement. They won't change as often. But fakes become less inviting when your interface grows large. So what I often saw happening is that a shared repository instance is used by a bunch of classes scattered throughout the project. So you have this get users function there, and then some other class needs to find a specific user. Then you want to delete a user, update some name, whatever, and then this repository grows larger and larger. If you have to implement this interface as a fake, then you need to implement the new methods that you add as well. It becomes long, and it becomes especially difficult when you're using a multi-module setup, because that often means that you have to duplicate your fake implementation, one in the first module and another time in the second module. And what you often end up is something like this, where you get one implementation of the function that actually does something, but you have some bunch of other methods that are not implemented. You have this to-do tag somewhere. So that's not really useful. And when you add a new function, you get a bunch of I'm missing this function errors. And if you've got multiple fake implementation, you need to chase all of them down, and that doesn't really help either. So what we've been using lately is a specific architecture style, which is called ports and adapters, otherwise known as the hexagonal architecture, because the pictures always show 6 ports. The number of ports isn't really important. Like, it doesn't have to be 6. Most of the time you have 2 or up to 4 ports. But 6 is always shown because it matches this hexagonal shape nicely. The goals of the main aim of this architecture is to decouple your core logic from the services that are needed by this core logic. So what you have, this core logic is the yellow center, and that consists of the essential algorithms of the application. So that's what your business, what drives your business. Like, we've got this algorithm, this is the most important of our app. And the services around it, like the database or the network call, can be replaced without changing the purpose of the application. So if you want to change from an in-memory database to a SQLite database or file storage, that shouldn't change the main purpose of the application. So if we have a look at the different shapes in this picture, we can see that the yellow center, that's the actual core. So those are the algorithms that are essential. And if you change code in this yellow bit, then you change what drives your application, change the actual essence of the application. Then you have the primary ports. Those are the 3 E-shape thingies at the top. And the primary ports are the main API of your app. So this means that they are the primary ports. They are main API in the sense that this is what your application provides, and the application can be some subpart of your entire system, or it can be the entire system as a whole. This is the main API. So if you want to do something, you call into these primary ports, and you get something out of the primary port as well. Then you have the secondary ports. Those are pictured as the lower 3 ports, and these are the services that are necessary for the core to function. Most of the times these are interface classes, and they are called by the core logic. So an example of a secondary port could be an interface to store some object, like some kind of repository pattern. And this interface, the interface simply specifies that the object can be stored, but it doesn't say how it can be stored. So it doesn't say this is a SQLite storer, it's a repository that can store something. These 6 ports are actually pictured as part of the hexagon. So that means that it's part of the core logic. What I want to say about that is that there are no other parts of the system that are actually allowed to use these ports either. I'll come back to that later. To couple this kind of hexagon to your the rest of your applications, you need adapters. And at the top, you would have primary adapters. So these are the blue thingies at the top. And primary adapter is basically the piece of code that bridges the core logic with the user. So this could be a unit test function if you want to test it, or it could be a controller-like function that interacts with the user interface and the core logic. And the primary adapter is the one responsible for interacting with the core logic. And at the bottom, then we have the secondary adapters, and the secondary adapters are the implementations of the secondary ports. So if you recall that the secondary ports are interfaces that are necessary by the core logic, then the adapters will implement those interfaces in any way that it sees fit. So it can be a small class, for example, that converts this storage request to the database, like it actually saves it to the database. But you could also implement it as a fake object. Yeah. So this is something that we often see. We have at the top left, you could implement a primary adapter as a user interface element. Like, okay, we're gonna the user presses some button and we're gonna call core logic. But you could also use a unit test function for that. And at the bottom, you can implement the secondary port as a database or a network call. So if you've got all this in place, how does it actually work? So we've got an instance of the application. So you create that and you create all the adapters around it. And the secondary adapters, so the 3 adapters at the bottom, you pass them to the core logic with dependency injection. When the user does some input, then the primary adapters will call into the primary API and of the core logic, and then the core logic will interact only with the secondary adapters it defined to do its job. When everything's done, then the output of this logic is returned back via the primary adapters. We'll have a look into an example later on that shows how this actually works. Now this all seems a bit complex or unnecessary. So when should you actually use it? It's really useful if you do if your application really is critical to be tested. So if you actually want 100% unit test coverage, then this kind of architecture style really helps. It's really useful if you do TDD, for example. If you want to be able to switch your storage mechanism, then you can do this because yeah, you already have the interfaces in place, so you really can easily swap out whatever you want to do. And it's especially useful for these long-lasting applications that change a lot, because the changes are really confined within one single hexagon. So that's ports and adapters. So if we go back to testing, how could you do? How does testing work when you're using ports and adapters? When you're testing, you're programming with the ports and adapter style, your core logic really stands central. So there's nothing else in the system you need to think about. It's more like, okay, I've got this problem, I want to solve it in the easiest way possible. So you can start with a clean slate, for example. Because your system under test, core logic actually defines these services it requires. It actually owns these interfaces. You can really easily create your tests, create your fake implementation of the test, and ensure that your tests stay stable and stay maintainable. So if you have these services in place, then your test suite can actually implement these secondary port services as fakes or stubs. And the nice thing about it is that these interfaces are really small by design, because they're not subject to change by some other component in this system. And on the other hand, they only provide the functionality that's necessary for the system under test to function, which are 2 of the solid principles that really help with maintainability of the system. So let's look into an example. This is something I actually ran into a couple of weeks ago. It's not a complex example, but it really shows it's a perfect example of how ports and adapters can work with this. So say we have some fitness application and the user has done some workouts. They're stored in a local database. Some are uploaded to the server, and now I want to display them in a nice list. So at the top left, you can see 3 workouts, and that are stored in a local database. And in the bottom left, you have 2 workouts that are stored on the server. And you have this duplicate in there, workout 3, and you want to get rid of it. So we need to have some logic in there that filters the duplicates, makes it into one nice list, and that can be presented to the user. So let's look at a merge function we can use for that. So this is the merge function we're going to use for that, and this is what we want to test. So the merge function takes two parameters, a list of local workouts and a list of remote workouts. This, yeah, and further down below, we are going to ensure that there are no duplicates in the resulting list. And at the end, we sort it by date to get a proper order as well. So this is our algorithm that's really important for us. Now let's look at how we can actually use this. So let's create a workouts provider class. So this is our core logic. This is the yellow part of our app. And we have this function workouts that returns this list of workout info. This is the main API of our application. So this is one of those secondary ports, primary ports, excuse me. And for now, you can see that I've omitted the dependencies necessary because we're not really sure where we're gathering from. And what the nice thing about the sports and adapters pattern is that your core logic actually can define the secondary port it want to use. So it actually defines the interfaces that it wants to use. So why not do that? So now we've got two dependencies. I have a local workout repository where I can call local workouts on, and I've got a remote workout service where I can download the remote workout from. So that's it. Then we have to define these interfaces, of course, and then we have something like this. We have two interfaces, one simple function, really easy. They're often I place these interfaces within the same file as the actual core logic because it really indicates the tightness of the hexagon as a whole. So it really indicates that it's owned. These two interfaces are owned by the actual core class. And in this case, I often annotate them as well with an secondary port annotation to indicate that it's actually an interface that the user needs to implement and not an interface that you can use. There's a subtle difference between that. So that really indicates like, okay, this is, if you want to use the workouts provider, you're gonna have to implement these two interfaces. So back to the testing part. We can now really easily implement this local workouts repository as a fake. Just like before, we have an empty list local property that we can return for the local workouts function, and we can easily swap the actual value out in our system and the tests. And the cool thing about this is that this implementation will only change if the workouts provider class changes, maybe, but it will never change because the database is changed or the way workouts are stored changes or something. And the same goes for the remote workout service. We have this local result property that we can return in a remote workouts function. So if we actually go to our test class, we can create a workouts provider test class, which does some setup and yeah, just create a fake local workouts repository, create a fake remote workout service, and inject them into our workout provider. This is a setup, and if we look at a unit test, that could look something like this. So in this test, we're looking into how can if a workout that's stored locally, that it is actually included in the end result. So starting with the definitions, like, okay, our local repository contains a single workout. Our remote service isn't important now, so we'll just let it fill. If we call our primary port, our workouts method, then we expect that our local workout is in there. So that's really the easy test that you can do. And let's take a step back into this setup of the definitions that our testables are returning. if you were to write this using Mockito, you would have something like this. So this would, call some bunch of stubbing methods on Mockito, ensure that the right values are returned. It is clean, but I'd say this one is a bit cleaner. But actually, if you you know that code is read a lot more than written, so yeah, this looks way better. This actually seems like a trivial example, but a lot of your test suites will actually end up exactly like this. Probably this is an actual test in our test suite, and all the other tests really look like this. So they're really simple, they are concise to the point, and that's a really good thing to have if your code is really critical. So let's have a step back and look at what we actually built now. This is an overview of what we built. So at the core, we have our hexagon shape. So now it is an hexagon because we only have 2 ports. We have the workhouse provider at the bottom, and we have our 2 secondary port interfaces. That's the entire core that we specified. And then in our test suite, we created these 2 fake implementations to be able to test our workhouse provider. If we also want to implement this in production code, because that's obviously something you want to do, you can create these adapter the secondary adapter classes that are basically bridges between your actual database or your server, and call these methods directly. So this adapter module at the right, the classes in there are usually very trivial. They only forward calls from the core module to the database, for example. And what's really funny here is that the database and the web module are hexagonal shapes as well. So the database, for example, it really defines its primary ports. It really defines what it can provide to you instead of reacting to what the core logic might need. So instead of the database having a direct dependency on some interface in the core logic, the arrows are pointed at it, which means you get a really stable database module, you get a really stable web module, and your adapter module is the one that does the conversion for you. So if your database changes, your core logic won't change, and if the core logic changes, your database won't change, which is really useful. So this basically shows what an architecture style can do for you when you're testing your code, and how you can avoid mocking libraries. But there are still cases where you want to use Mockito or Mock-A, whatever you're using. These dummy objects, they're really useful if you don't need to actually call into them in the production in your test code. So a mock function, if you call the mock function, you're just creating a dummy object, you're not using it, let it go. That's really useful to use Mockito for. And the other one is for event callback invocations. In this case, we have an events interface, which has a function of button clicked, and in our test suite, we want to ensure that this on button click function is actually invoked. The Mockito syntax for that is really clean, so you can just call this mock function for the events interface and verify that this on button click function is called. Some people have been advocating to remove these calls as well, because you could just implement it and set some flag to true. I feel that this implementation is a bit cleaner than that because of the simplicity it actually shows. So if we want to wrap up, I think I hope I made clear that fakes allow a more natural way of providing test doubles and a more stable way. And that a specific architecture style can actually help to keep your test suite clean, keep your fakes small, keep your concerns separated. And that mocking libraries can still be useful, but please use them sparingly. And with that, I've reached the end of my talk. So thanks for listening. Yes.
Are there any questions in the chat? Thanks a lot for your talk, Niek, by the way. Really interesting. Let's also see if anyone has questions in the chat. We have a small delay. Or a lot of claps. Jof just says, awesome stuff. Exclamation mark. I'm curious, how much maintenance does the test doubles cost?
So in terms of maintenance, you have to implement them. So that's some kind of burden. You're going to need more code. So you need to introduce more interfaces. You need to introduce more adapter classes. But they're so small, they will only change if your core logic changes or if the other side of the core logic changes, like the database, for example. And that really doesn't happen that often. And if it does, your adapter, your production adapter class is really trivial. It's really small, so that isn't hard either. And at the other side, your fake implementations are just as small. So the maintenance cost is relatively low. You're gonna need a bit more setup at the beginning if you write it, but afterwards the maintenance is really low because of this decoupledness.
Okay. And from Yolanda, how do you prevent the adapters from becoming too large?
Yeah, that happens a lot. What I've seen a lot is that some concerns change, like instead of grabbing stuff only from a database, you're now introducing a network class. And in that case, it's often useful to extract this adapter into a hexagon of its own. So instead of having two hexagons next to each other, one for the core logic that does what you want to do, and the other one, for example, the local thingy, you're now going to have three hexagons that bridge again, and this center hexagon is then the way to test. So to give an example, you would have something like this if your user interface says, I want a list of workouts, and then your adapter says, I can do that with only the database. So that's just a direct adapter from the user interface to the database. And then this network requirement comes in. Then it's really easy to fall for the trap to just include the network and the combining in your adapter class. But at that point, you should recognize that and see if you need to extract it to a new core module.
Cool. Then another question about ports and adapters. If we call the yellow part the use case of clean architectures, what are the equivalent of primary and secondary ports?
So this is, I'm not really familiar with use cases in that sense, that it's broadly used in the Android community. Ports and adapters is actually discussed in this clean architecture book. let's see I think I'm gonna need to look into the use cases more to have a real good answer for that.
We can always follow up on that.
Yeah, exactly. So I'll follow up on that in the Slack, I guess.
Cool. How do we write a fake implementation for success and failure cases at the same time? Any inputs?
I'm going back into my slides. So let's see. This one, right? So in this case, I've introduced a try, and now you can really easily swap a try and try.success for a try.failure. You can just program anything you want. So you can set if you don't want to use tries but set an error, you can have two fields next to each other, and in your remote workouts function, check if the error field is set or not and use that. So you can actually do anything you want. So I think that answers that question.
We will have to wait on Niek for that. If there are if there are no other questions anymore, I think we can start rounding up. Niek, thanks a lot for your talk, for being here. For all other people, let me. No. One second. Okay, this is only for me. Well, yeah, thanks a lot. Thanks a lot again, Niek, for your talk. I hope everyone enjoyed the live stream. Definitely give us a follow on Meetup, Twitter. You can look up the speakers and subscribe for future events. Thanks a lot for joining all, and thanks, Niek and Alex.
Thanks.